My dear students of CE806, Structural Analysis and Design of Concrete Structures, Sessional 2. Today we will be discussing about the live load influence lines for live load and the moments for live load moment. Influence lines for live load moment and the moment calculation, total moment calculation. First of all, we will discuss the influence lines for live load moment. Previously, first of all, we will discuss the influence lines for live load moment. Previously, we have discussed the influence lines and shear forces for live load and dead load. Now, we will be discussing influence lines for live load. That is, in the live load, there will be wheel load and distributed load. Here also we will start from point 1, which is a simply supported span of 60 feet, and we have to design the half the bridge because on the other side the bridge is similar. That's why we will choose points 1, 2, 3, 4, 5 and 6. And as you see, there are 4 figures only. There will be no moment at points 2, location 2, and no moment at location 6. That's why in this case, in the moment case, there will be 4 figures, and we will be finding out the live load moments for at these 4 points 1, 3, 4 and 5. 1 is a simply supported one of 60 feet span. If we put a load at the center, the reaction will be half, and the moment at that point will be half into 30. That means 15, and it is 15 kip feet for each kip of load. And our load will be in wheel loads, will be bigger loads. We will be putting those values when we will calculate the numerical values of this moment. Here we will be influence line is drawn or calculate the ordinates of influence line is calculated on the basis of unit load, and our unit load is 1, and that's why the value is half into 30 is equal to 15 kip feet per kip. If we put a value, our wheel load after multiplying with different factors of 16 kip wheel load has become 58.1 kip, 58.1 kip, and 4 kip load has become 14.5 kip. Now, as at the center, the moment coefficient is the influence line value at the center is 15, at the two sides it is 0, 0. Now, we will try to put this 3 wheels of 58.1 and 14.5 in such a way that it gives maximum moment. Naturally, the 58.1 load will be at the center, and the 2 other loads will be at the right and at the left. This is the influence line, and the 1.04 load will be coming all through this span. Wherever it gives the positive value added with this wheel load moment, then we have to put this 104 kip per feet load from 0 span to the final end of this span, the 60 feet span. And this is influence line for at moment 1, at location 1. At 2, there is no moment because this is a hinge point or roller point. Therefore, there will be no moment at the point 2, but there will be next moment will be at point 3. This is a cantilever part of 30 feet span. This is a cantilever part of 30 feet span. If we put a load at the cantilever at a distance of 30 feet from the support, the moment will be 30 kip feet, and that is the ordinate is, and it's a negative moment. That's why the figure is at the bottom, at the lower side of this reference line. This is 50 kip feet per kip, and if we put the load at just at the point 3, there will be no moment. That's why the influence line at that point, the ordinate of that point will be 0. And if we put the load in the right end of the 60 feet span, then there will be no reaction at support 3. That is why the reaction will be 0 and the moment figure will be 0. And if we put the value at 2, wheel load at 2, the moment will be this 1 into 30, that means 30 kip feet. That's why, and this moment will be negative. This is the influence line for the for point 3. There is a negative moment, and the 1.04 kip per feet load will be put all through the distance from point 3 to point at the end of this at the right end of the simply supported span, and the wheel loads will be put in such a position that gives us maximum value. That's why we will be putting one wheel load at the point at the tip of this cantilever, that is point 2, location 2, and as the right hand triangle is a bigger one. That's why the other two wheel loads will be at the right hand side of this triangle, and that's why we have put the next 58.1 kip at a distance of 14 feet, and the other one is at the end of 28 feet, and the load is a 14.5. This is influence line for the position or location 2, and the next location is point 4. If we put a load at point 4, 1 kip load, then there will be 1/3 reaction. As you see that the divisions are like from support to support, they are 90 feet, and we are putting this value, the wheel load at 30 feet from the right support. That's why the reaction, just by observation, we can find out that the reaction at the left support will be 1/3, and at the right support it will be 2/3. If we multiply this 1/3 reaction at the left support, we will get the influence line at point ordinate of the influence line at point 4, and that distance is 60. And if we multiply 60 by 1/3 by 60, then that gives us a value of 20 kip, and that is 20 kip feet per kip. This is the maximum ordinate here. And if we put the wheel load at point 6, there will be no moment, and that's why the ordinate that point will be 0. And again, if we put the wheel load at point 3, there will be no reaction at 6, and there will be no moment at point 4. But if we put this value at point 2, put this wheel at point 2, there will be reaction. There will be a reaction, and this reaction will be 1/3, because if we put a value 1 kip load at point 2, 1 into 30, that divided by the other hand, the reaction at 6 will be 1/3, because we have to divide that by 90, and that's why the reaction will be 1/3, and the moment at this point will be at point 4. At point 4, if we put the value at point 4, then the reaction is 2/3. And for finding out now, again for the cantilever part, if we put the load at cantilever portion, the reaction at point 6 will be 1/3, because we have to multiply this 1 into 30 divided by 90. The reaction will be 1/3, and the moment at point 4 will be 1/3 into 60, that is 20. Then this negative moment will also be 20 kip feet per kip. When we will be putting the load at 2, the moment at point 4 will be 20 kip feet per kip. And if we put the wheel load at right hand side of this simply supported span, the reaction at 6.6 will be 0, because there will be no reaction at point 2, and if there is no reaction at point 2, there will be no reaction at point 6. That is why the ordinate will be 0, and we will be having a positive moment and negative moment. We have a positive moment and negative moment triangle, and the wheels will be placed in such a way that those gives us the maximum value for the positions. And next inference line is for point 5, location 5. It is 30 feet from the left support and 60 feet from the right support. If we put a wheel load, one kip of load at point 5, as the span is 90 feet, and we have put this value at 1/3 of this span, there will be the 2/3 moment at the left hand side, and this 2/3 multiplied by 30 is 20, and this 20 kip feet is the ordinate at location 5, and naturally there will be no moment if we put a load at point 3, there will be no moment at point 5, and if we put a load at point 2 right hand side, there will be reaction of 1/3, because if we take moment about point 3, the 1 into 30, that divided by 90 will give us a reaction value at 0.6 as 1/3, and if we multiply this, if again I am telling you that we are talking about this and 1/3, and if we multiply this 1/3 into 30, that will give us a value of 10. That is why at the bottom the IL for moment at 5, the negative moment is 10 kip feet per kip, and the positive moment is 20 kip feet per feet at location 5, and when the load is at location 5, and when the load is at location 2, there is the inference line ordinate will be 10 kip feet per feet. And now we have to put the wheel loads, 3 wheel load. One is 58.1 and 14.5, and the uniformly distributed load of 1.04 kip per feet, and for finding out the values of the actual moments depending on the location of the wheels and the distributed load, we will calculate this value, and we will show this in the next page. Wheel load moment and distributed load. We have separated this wheel load moment and the distributed load moment, and for M1, that means when we want to know the moment at the point 1, that means at the center of the simply supported span, then we have to put 15 is the ordinate and 58.1 is the load, plus 15 is the ordinate, 58.1 is the load, and the ordinate is 15 will be reduced, and that reduced value will be 30 minus 14 divided by 30. In a triangle, from the triangle properties, we can find out this ordinate at a distance of 14 feet, at a distance from the center to 14 feet. And in this, and if the smallest wheel will be at a distance of 30 minus 14 again, and this will give us 30 minus 14. There is a mistake, I believe.
16. 30 minus 14, 16.
No. 30 minus 30 minutes. Calculating this and multiplying and adding, etc., doing the arithmetic, we got a value of 14.52 kip feet. For the next one is minus M3. At M3 the sign of this moment will be minus, and at 3 we have to if we put these values in the bigger triangle, that will give us a maximum value, and 30 into 58.1, 30 is the ordinate at the peak of this triangle, and then 30 into 58.1, and that is to be deducted from 60, 14. 14 is to deducted from 16 and divided by 60, and that gives a value, and the last one is 14.5 cubic feet, is the ordinate at the top is the 30, and we have to multiply that by 60 minus 28 by 60, this ratio, and this gives us a minus 3311 cubic feet cube or cubic feet, whatever is the moment unit is, and there is you can repeat the control. We'll go to 0.4. Positive moment, you see that in the triangle, the maximum ordinate in the influence line triangle, the maximum ordinate is 20 cubic feet per cube, because if we put a load at 4, the location 4, there will be in the left hand side there will be location reaction of 1/3, and if we multiply this by 60, then the moment coefficient will be 20, and the ordinate will be 20 cubic feet per cube, and if we put a value at 0.6, there will be 0 moment, and if we 0 moment at 0.4, and if we put a value wheel at 0.3, the moment will be 0, and if we again put the value at the cantilever part, that means at tip of the cantilever, that is 0.2, there will be reaction at the 0.6 will be 1/3, and if we multiply this by 1/3 into 60, that is 20 cubic feet. This is 20 cubic feet per cube of load, and if we next we will go to 0.5, and if we put a value of 1 cube at 0.5, there will be a reaction of 1/3 on the left hand side of the there will be reaction of 2/3 at 0.6, and with this 2/3, if we multiply this by 30, then the ordinate maximum ordinate is again 20, and if we put a value, if we put a load at the tip of this cantilever, that is 0.2, then it will give us a reaction of 1/3, and if we multiply this 1/3 by give us a value of 1/3 into 30 is no 1/3 into 30 is 10. I'm sorry, and the left hand triangle has a maximum ordinate of 20, and the right hand triangle has a value of 10, and these are the 4 influence lines. And calculating M4 in page 3 for calculating M4, M4 plus and M4 minus. The M4 plus and M4 minus is similar. M4 plus and M4 minus is similar. M4 plus, we have to multiply this M4 for calculating M4 plus 58 is to multiplied by 20, and plus 58 is to be multiplied by 20 within bracket, that is to be multiplied by 60 minus 14 by 60, and for again 14.5 into 20, and that is to be multiplied by 60 minus 28 by 20. That gives us a value of, if we solve this equation, then we get a value of 2208 keep fit. When minus M4 is similar to plus M4, because only the sign is different. The plus M4 is plus and minus M4 is minus. But these two triangles, two triangles are similar because the ordinate is, maximum ordinate is 20 and the length is 90. And both of these are a similar triangle. One is positive, another is negative. That's why the values will be minus M4 will be minus 2208 and plus M4 will be 2208. And for similarly, as for location 5, the triangle is similar with that of the location at 4. That's why we have just given the value directly, because plus M5 is equal to plus M4, and that's why the numerical value is 2208, and the minus M5 is half of M4. That's why this value directly we can calculate half. We can take half the value of 2208, and that comes as 1104. This is wheel load moments. Next is distributed load moment on the right hand side. Here for the M1, the maximum ordinate is 15, and this is a triangular figure, and that's why half into 15 and into 60, and the load is 1.04 kip per fit. And you can see that if we put this value at this triangular inference line, then the distributed load moment for M1 comes as half into 15 is the maximum ordinate, and 1.04 is the load per running foot, and the length is 60. That's the value is 468. For M3, the length is 90 feet and the maximum ordinate is 30. That's why, and it's a triangular form, the half into 30 and 1.04 is the distributed load and 90 is the total length of the span, or this influence line diagram is 90. That's why then it's, after doing the arithmetic, we have got this 1404. And for plus M4, for distributed load, for plus M4, half the triangle is 90 feet and the load is 1.04 kip, and the ordinate is, maximum ordinate is 20. It's a triangular shape, and that's why half, and that gives us a value of arithmetic value of 9 plus 936. The other one, similar triangle, that's only the sign is negative. That's why the minus M4 is minus 936, and M5 is again similar to M4. That's why it's 936, and the right hand portion, the triangle has the same length of 90 feet, but the ordinate is half. That means ratio is 20 to 10. That's why this value is half of 936 is equal to 468. This is simple arithmetic. You can understand how this has come as 648, 468. And this is for this inference line and moment calculation for the distributed load and for the wheel loads. Wheel loads are, we have to put only one truck with which wheel loads will be considered, and for the rest of the span we have to put this distributed load, which will give us the equivalence of these other wheels. Those will be present, while these moments will give the maximum values or critical values. That's all for today. Hello. There is something more. there is some other point here. That was the live load moment calculation, and previously we have calculated the dead load moment. In the beginning, the earlier classes, we have calculated the moments at different locations. We have critical location is 3, 4, 5. From the right hand side is 3, 4, 5. In these three points, there will be moments. And dead load moments, if we go back to this dead load moment calculation, we will be finding out the values of minus 3486 kip feet for location 3 and 654 dead load. If we go to the dead load figure, you will find the 654 moment, negative moment at point location 4 and plus 795 moment at location 5. And wheel load, as we have previously we have calculated, wheel load moment will be at location 3 is on minus 3311, and there will be a positive and negative moment at location 4 will be is plus 2208 and minus 2208 and wheel load moment, and at 5 there is 2208 and negative is 1104. We have picked these values from the previous page, and you can compare this and check it. And distributed load is at point 3 is 1404 minus, and at 4 is 936 plus and 936 minus, and also at 5 it is 936 plus and 936 plus, but at 4 it is 5, it is 468 minus. And design moment will be coming from this. At the point 3 all moments are negative moments, that's why those will be added all together, and that gives us a value of 8201. This 3486, 3311 and 1404. In the point 4, we have to find out, we will have to find out the design moment, and this point is little critical because this minus 654 dead load moment will be always there, and this is minus. And wheel load moment will be, sometimes it will be plus and sometimes it will be minus. These values are 2208 and 2208. And again the distributed load will be, sometimes it will be plus and sometimes it will be minus. And so in calculating these values, this minus, minus and minus, dead load minus, wheel load minus and distributed load minus will give us a value of 3798 kip feet. But when there will be for some position of live load, there will be minus 2208 moment and minus 93608 moment, and these we have calculated. But when this plus 2208 moment will be coming and plus 936 keep 936 kip feet moment will be coming, simultaneously this dead load moment will always be minus 654. Whether lab load is positive or negative doesn't matter. That's why when this positive moment will be coming of 2208 and 936, simultaneously there will be a minus moment, which is the dead load moment. Is once the bridge is constructed, this moment will be there for infinite time. That's why this 6 from positive moment, this minus 0.654 is to be deducted for getting the actual value for which we will be choosing the steel area and stirrups, etc. Steel area reinforcement, and that will give us a value of 2490 kip feet cubic feet. For point 5 also there is a positive moment for dead load, and there is a negative moment for wheel load, and negative and positive moment for wheel load. In one case the positive moment is 2208 and negative moment is 1104. In the other case it is 936 and 468. In this case this 975 cubic feet load will always be there, whether there is wheels or not, whether there is live load or not. That 795 cubic feet load positive moment will be always there. That's why we will add this with this positive moment, a positive wheel load of 2208 and distributed load of 936, and that will give a big positive moment of 3939. But when we will be calculating the negative moment, then this dead load positive moment will be always there. That's why while this negative moments will be coming minus 1104 and minus 468, where this total negative moment will be reduced by this positive moment of 795. That's why in the last column, for in the 5 row last row 5 column, we have put this 795 as the dead load moment, which always present is a positive. That's why when the wheel load will give us a value of 1104 and the distributed load will give us a value of 468, this is to be for getting the maximum minus moment at this point, we have to deduct this 795 positive moment, because it will be always present there. Once the bridge is constructed, this moment will be there always. And this much for the day. And I believe it's a little complicated and a little tough, but you have to try to understand this very carefully, very minutely, and taking time, and then you will be able to understand this thing. This is a little bit tough part of this bridge design. Thank you.